master of electricity. Electrical system design. Class 1. See, the electrical system design consists of 4 important points. Based on the 4 important points, everyone can design a better electrical system. See, let's check what are the 4 important points. The point number 1 is that we have to understand about the technical requirement. And the technical requirement means the type of load. As we know that most of the industrial loads, 90% of the load may be the induction motors. And there will be some kind of heating load, lighting load, and everything. Most probably, the type of load will become the motors. Motors means induction motors, and nowadays the DC motors also we can see in the industries. Another part is based on the capacity, the motor capacity, we have to select the cables, switches, and everything. Then again, based on the motor capacity, we have to choose the source. That means the transformer capacity, if the load is being run through the generator, we have to design the generator capacity also. When we discuss about the source, we have to find out the source voltage. If the motor capacity exceeds some rating, we have to go for the HT supply. So normally, normal motors, small capacity motors, all being run through the LT supply. Higher capacity motors, we have to go for the HT supply. Maybe 3.3 kV, 6.6 kV, 11 kV type. So the first point, the technical requirement means the type of load, that means the power load, light load, heating load, and like that. Then source capacity, supply voltage, in every state there is a regulatory commission working with that. So the regulatory commission decides at what voltage how much load that we can connect. So for every range of connected load, the regulatory commission insists the supply code or related rules and regulations to limit the connected load connected to particular system voltage. So the regulatory commission frame supply code. Based on this, how much load can be connected to particular voltage. So source capacity and the supply voltage and the type of load. These three things determine the basic technical requirement. And the second point, theoretical principles. See, for every electrical design, we have to understand the basic theory behind the design practice. For example, there will be some kind of thumb rules that we have to follow for easy electrical design. For example, for induction motors, we already studied in our classes like that induction motor takes 5 to 7 times of normal starting current, normal running current during starting time. See, every induction motors takes 5 to 7 times of the normal running current during the starting time. So, for electrical designs which consist of so many induction motors or small capacity or the bigger capacity, for each type of motor we have to follow these kind of theoretical principles that we studied during our college time. Or just keep it in mind that induction motors will take 5 to 7 times the normal running current while starting. So we can, if this is entirely for the direct online starters case, we have to use the starters for induction motors. The starters may be of direct online starters, DOL, and star delta, then auto transformer type starters, everything. Rotor resistance type. And there will be further type of starters and we can discuss later. So for every induction motors, we will be having some kind of starters with that. Based on the type of starter, we can control or design the cables, switch rating, because of for every type of starters, there will be some the starting current requirement will be somewhat different. While we are using the direct online starters, the starting current will be much higher when compared with the star delta. So if you are using the auto transformer type or auto resistance type or something, soft starters, as we commonly say is the soft starters, the starting current will be reduced. So the type of starters can contribute a lot of technical data while designing the electrical part. So depending upon the starters, we can select the cables for the induction motors. And the third part is practical limitations. See, while we are having the first two parameters like a technical requirement and we go for the electrical design, the first part is computer technical requirement. We know the type of load and the capacity of the motors, and we go for the transformer capacity, source voltage, source capacity, generator capacity, everything. And while trying to design, we have to follow some kind of thumb rules or practical cases, like the type of starters of the motors. And based on the starters, we will be designing the cables and the switch rating for all these case of designs. We have to understand some basic theory behind it. And even though we are having all the first two principles in our mind, there will be some kind of practical limitations. See, for example, the cable size, selection of cables, and selection of switches, and switchboards. Here, the switchboard selection is something important. Whether we go for the distribution board or board may be further classified as vertical distribution board, horizontal distribution board. That's a normal DB, and we often named by some kind of a power DB and light DB, everything. So the common name is distribution board. So up to what load capacity we can go for the distribution board, and depending upon the type capacity of the motors or depending upon the rating of the load, we can go for the switchboard and everything. There will be some kind of design parameters, criteria, practical limitations are there. We will go in detail in further classes. And the last important parameter is the financial constraint. In every electrical design, the financial part is the important one. So, while designing industry, an industrial load, the majority of the load, as we already discussed, that will be induction motors. And if you are having the financial constraints, then the selection of starters, that's an important area that we have to look into. The direct online, any motor that can be driven through the direct online starter mechanism can also be driven easily and efficiently by using the soft starters. So DOL starters and soft starters. The cost will be lower for the DOL and the cost will be higher for the soft starters. See, based on the DOL design, DOL starter design, the cable size will be higher. Here, the cable size will be lower. So again, the switches and protection mechanism, everything, heating effect will be much higher here. While we are using the soft starters, the cable size and switches and other protection mechanisms, everything is less complicated. So the financial constraints and financial matters come into consideration. So depending upon the financial capacity of the owner of the installation, we can select the type of starters or we can provide further protection mechanisms, everything. So we are dealing with the four important points: the technical requirement, theoretical principles, practical limitations, and financial constraints. So in every electrical installation design, in every electrical designs, we must understand the technical requirements. So while we are going to a discussion with with the owner during the consultancy time, we have to first understand the technical requirement. Then the theoretical principles. Technical requirement can be understand from the owner of the installation. Theoretical principles in our mind. That means knowledge. Knowledge may be again connected with the practical limitations. Again, these are knowledge while theory or practical. Then financial part, financial constraints. See, these four parameters have to be considered while going for the electrical system design. So, being a consultant or being an electrical engineer, you have to follow the four important criteria before submitting a detailed electrical schematics and go for the work. So this is the end of the first session of electrical system design. This is class 1. And subscribe to Master of Electricity. Me. This is a YouTube channel. Link. Please subscribe.